Hello everyone. Today we'll see the electric field which is part of the electrostatics. So let's start. So electric field basically defined as the region or space around a point charge or system of charge, right? Around which these charges have their electric effects. So I am writing the definition. So electric field can be defined as the region or space around a point charge or system of charge in which they have their electric effect, right? So this is the space or region around the charges, right? Now there is another term we define, that how much the electric field is powerful at some point and less powerful at some point. That means I am saying that how strength the electric field is. To define that one, we define another term that is called electric field intensity. So that is electric field intensity. So electric field intensity basically tells you how much the electric field is strength, or how much the electric field is powerful at that point. Or you can say that the strength of the electric field quantitatively you are defining by this electric field intensity. So I can say that this is a physical quantity tells about the strength of electric field, right? So this is your electric field intensity. In books or when you are doing the problem, this electric field intensity also name as this electric field, right? So whenever you see electric field, means you have to keep in your mind that they are talking about quantitatively how much strength the electric field will be. So this is a, so generally it's also called as your electric field, right? This is also called as electric field, right? So electric field intensity or electric field due to system of charges or point charges, now we will define, right? How much quantitatively it is coming or how it is depending on the distance, we'll see, okay? Or charges, we'll see all these things. So let's say there is, this is system of charges. This is system of charges, right? And this is a point P which is some distance from the point charges, and you put a charge Q naught, let's say here, Okay, this is called a test charge. We will talk about this test charge. Okay, this is a test charge basically. Now you know that if the system of charges is, let's say it is positive, obviously this will be q naught will be repelled by this system of charges, right? And let's say this force is, I am writing F. Okay, clear? So now I am defining the electric field due to system of charges, or electric field intensity due to system of charges. So it's defined as electric field due to the system of charges is equal to force on q naught due to system of charges divided by q naught, right? This is the electric field due to system of charges, right? So this thing you have to remember, or in words if I write electric field at point P due to system of charges is defined as the force on q naught due to system of charges divided by q naught. That's what we have talked, right? Okay, so I can write now force will be what, or electric field will be what, force divided by q naught. First thing, electric field is a vector quantity, right? Second thing, can you write the unit of the electric field? You will say yes, this is force per charge, that is Newton per coulomb, or we will study in the next chapter, that is volt per meter. Okay, now can you write the dimension of it? The dimension of it will be Newton per coulomb, so you can write m1 l1 t minus 2, that is force dimensional formula, divided by c equal to I into t. That will be your m1 l1 t minus 3 I minus 1. This will be the dimension of the electric field. Okay, now you see here, now if I say q naught is your positive, then you will say that electric field and force parallel, right? Second point, if q naught is your negative, electric field and force is anti-parallel, right? So what does it say? You just to be very sure about this is the electric field due to the system of charges, and F is the force on the charge q naught by the system of charges. That should be clear, right? Okay, now if I ask one question, let's say, depending all this thing, the question is saying that, let's say there is some system of charges is there, and at some distance you put, let's say, 5 coulomb charge. You put 5 coulomb charge. Now they are saying that force on 5 coulomb charge is 10 I cap plus 20 j cap minus 30 k cap. Find electric field due to system of charges. So basically this force is due to the system of charges, right? Now they are asking find out the electric field due to system charges. So in solution, you know that you immediately tell that this is electric field equal to F by Q naught. So electric field will be how much? F will be how much? 10 I cap plus 20 j cap minus 30 k cap Newton divided by 5 coulomb. So it will be 2 I cap plus 4 j cap minus 6 k cap Newton per coulomb. Okay. Now next question we'll see. One more question. So there is again system of charges. Now at point P I put minus 5 coulomb charge, right? Now force on minus 5 coulomb charge is F equal to, let's say I take 5 I cap minus 10 j cap plus 15 k cap, and obviously unit will be Newton, right? So this is obviously Newton, right? So I'm writing here, this is Newton. Now find electric field due to system of charges. So what we will do? So we will tell that electric field will be F by Q naught. So F will be how much? 5 I cap minus 10 j cap 15 k cap. Q naught is minus 5, right? This will be Newton, this will be Coulomb. So how much it is coming? Minus I cap minus 2 j cap plus 3 k cap Newton per Coulomb, right? So this will be I minus I cap plus 2 j cap minus 3 k cap Newton per Coulomb, right? So you have to put that value here, that minus 5, right? Clear? Now let's do one more problem. Depending on this relation, I am doing the problems, right? This relation I am doing the problem. Let's take this is the ground, okay, and there is some negative charge is there. A charge is minus q and mass is m, right? And they are telling that it is at rest. And second case, you can write this one, case number 1. This is case number 2. So there is some positive charge is here, that is plus q, or and mass is m. Now also it is at rest, right? The question is, and the direction they have given here, this is your x, this is your y. The question is, find the electric field in vector form for both case. Right? So how will find out? Let's go for the first case. So you will tell, if this charge is at rest, that means obviously mg is downward. Okay, that means the electric force on it should be upward, then only net force will be 0, then it will be at rest. Okay, now you know that here I have told here that if q naught is negative, then electric field and force will be antiparallel, right? So you use that one, you will say that force will be upward, means the electric field will be here downward. Okay, now tell me, for rest case you will say that F equal to mg. F equal to how much? Q into E. Q into E, because you see here na, this is Q equal to F, right? Q into E. I am writing the magnitude. This is equal to mg. So electric field mg by q. Electric field will be mg by q. Now in the vector form, if you want to write, this is given your x, this is given your y, and electric field is downward. So electric field vector form will be mg by q minus jk. Clear? Now go for the second case. In second case, obviously you will tell that obviously the mg will be downward and the force obviously upward, that is electrostatic force. Now if this charge is positive, then you can say that force due to system of charges or anything or point charges, this force due to this charge, force due to system of charges or point charges, always parallel to the electric field due to that charges, right? Here force on this plus q charge due to other charges will be upward, so electric field due to the other charges also upward. So I can say that F equal to mg. So I can write q into E equal to mg. So E equal to mg by q. Now this charge is positive, so electric field and force will be along upward, right? So you can say that electric field will be mg by q plus jk. Got it? This is clear, right? Okay, so now let's do one more problem, then we'll go for the electric field due to point charges, right? So this is basically a projectile motion problem. So, and we may have done this type of problem previously. So let's say this is the y direction, that's how you take in the projectile, and this is x direction, and at this point there is a charge q and mass m, particle is there. Now you project it with u at some angle theta, so that what will happen, it will go like this and it will fall. This is our previous case, you know all these things. You can find out the time period, you can find out the maximum height, you can find out the range, everything you can find out. Whatever we will ask, you can find out easily. Now one thing, extra thing what I am doing, due to this charge I am just putting a electric field on the top. that is from top to down, that is minus Jacob direction, right? So with this situation, I am asking you some question. I am asking you, you just find out time of flight, you just find out maximum height, you just find out the range. So this is the same thing, only one thing is going to change, that acceleration along minus Jacob. So you can try this one. So what will happen basically, you just see here, acceleration along x is 0 because there is no acceleration along x. Only acceleration y direction is there. Acceleration along y is there. Now you can say that here the acceleration is downward, that will be your g. Along with that, there will be E, electric field is there, so the net force will be downward Q into E, because Q is positive we have taken, right? So you can say that the acceleration this side will be, net acceleration will be G plus QE, or capital Q we have taken, na? Okay. So capital QE, that is the force divided by the mass, that will be the acceleration downward. So if this is acceleration downward, we can put a negative sign. Previously we write only G, now we have to write QE divided by M. Clear? This is going to change, nothing is going to change, only this thing, the acceleration along y is added up with QE by M, because you are applying the electric field. And just remember that this electric field is basically uniform. This electric field is uniform. We'll talk about what is uniform electric field. Just here you just think that this electric field is uniform. Okay, now we have to find out all these things. Time of flight, you know, I am just applying the directly formula, right? Because you know everything. So time of flight will be 2u sin theta, that is you right now, 2u along y direction, speed along y direction, velocity along, 2u sin theta divided by g plus qe by a. Or you can, you know this formula, right? Previously if this was not there, this qe by m, you just write down 2u sin theta by g. This is your time period, right? Okay, this is your time of flight. Clear? Now tell me the maximum height it will go. Directly I am using u square sin square theta divided by 2g we use. Now g will be g plus qe by m. Now the range are equal to, you know that will be what, u square sin 2 theta, u square sin 2 theta divided by g. Now this will be g plus qe by m. Like that you can find out all these things. Okay, now we'll see for the electric field due to point charges. Okay, so electric field due to point charge, right? So this is the same definition, just see here. electric field we have defined due to system of charges or electric field intensity. Basically we are finding out electric field intensity, but I told you, right, that same name we called electric field. So the same thing I am doing here. Instead of wherever I write system of charges, I just put point charges. Like this electric field I defined here, you see here, I told the force on Q naught due to system of charges. Here I put force on Q naught due to point charges. Clear? So I am writing, you just see. So instead of putting system of charges, I put a point charge Q, right? And at some distance, let's say I take a P point, here I put Q naught charge. Obviously, if this Q is positive and Q naught is positive, the force on it will be along this direction. It is clear. So if this direction or this vector Q2P is R vector, so I can say that this will be along R cap direction. Force will be along R cap direction. Clear? So electric field at point P due to Q, right, that we write E vector. So E vector can be written as force on Q naught due to Q divided by Q naught. This will be your F divided by Q naught. You know that this will be Q naught Q divided by R square divided by Q naught along R cap direction. How much it will come here, you see, this will be Q divided by R square along R cap direction. So I am writing here electric field due to positive charge Q will be KQ by R square along R cap. R cap is defined as radially outward, right? This is radially outward means you see here, this is Q charge which is radially outward, right? This is your radially outward this direction, right? So electric field due to a point charge Q, capital Q, at a point P is defined as force on the Q naught due to Q divided by Q naught. Clear? If I put there minus Q, if this is minus Q and I want to find out the field at this point, put Q naught, obviously you will tell that the force will be along this direction. If R vector is along this direction and force is along this direction, I can say that force will be negative R cap direction. So electric field at point P or electric field due to the point charge at point P is equal to KQ by R square minus R cap direction, which we called it is radially inward, right? Radially inward. So again I am repeating, electric field due to point charge capital Q at a point P can be defined as the force on the charge Q naught by capital Q divided by Q naught. And if the charge is positive, the electric field due to the charge will be radially outward. If the charge is negative, electric field due to the negative charge is radially inward. Okay, these two things you have to remember. Okay, so now one thing you just observe here, electric field is not depending upon the q naught, right? Because in the electric field expression, the kq by r square, only capital Q is there and the distance is there from where you want to find out the electric field due to the charge. So there is no dependency on the Q naught, right? So what I am saying, what I want to say that, let's say this is Q charge and I want to find out the electric field at this point P, which is r distance from here. Oh, I can say that electric field at point P due to the capital Q charge, simply kq by r square. If charge is positive, this will be r cap direction. Now, if I take a minus q charge and I want to find out the electric field at this point, I will say that electric field at point P is simply kq by r square. This distance is r if I take, minus r cap direction. Clear? These two things you have to take. And r is the distance between the charge q and the point P. If you want to write down in the vector form, you can write this one as kq r vector divided by rq. This is basically distance, and this also you can write kq by rq minus r vector. Okay, this thing you have to keep in your mind. Okay, r vector is the vector from q to p. Depending on it, we will do one problem, then that will be clear to you. One more thing I want to tell. So electric field magnitude basically is equal to kq by r square, right? So as the distance increases from this point charge, the electric field is keep decreasing because it's 1 by r square. So someone tell me that to draw that graph, electric field versus the distance r, I'll tell that the graph will look like this, right? Because it's 1 by r square. So in other words, you can say that electric field is proportional to q and proportional to 1 by r square. More the charge, more will be the electric field. More the distance you go from the charge, the electric field will be keep decreasing with 1 by r square term. Okay, the electric field due to the point charge will be look like this. Clear? Okay, so depending all these two formula, just do one problem, then it will be clarified. Okay, let's say I am taking a charge at this point, that is, let's take 5 coulomb, and this point position is given 1 2 1, and they told me to find out, the question is asking to find out the electric field due to this 5 coulomb charge at point P, whose position is 6 1 2. Okay, we have to use this formula and this formula, or if there is charge positive we can use this one, or charge negative we can use this one. Okay, let's see. So now I have to find out electric field at point P. Let's see how I'll do. you write down that formula. Electric field is equal to kq divided by rq into r vector, because q is positive here. Now tell me, r vector, I told that starting from this charge going to the point P. So r vector basically defined as 6 minus 1 I cap plus 1 minus 2 j cap. You just see here, na, 6 minus 1, like that you do vector obviously, right? You remember a vector, this is your r vector, you can think that, and this r vector can be written as this position minus this position, you know that, right? That thing I am applying only. Okay, so plus 2 minus 1 k cap, right? 5 I cap plus minus 1 j cap plus 1 k cap. 5 I cap minus j cap plus k cap. This will be our vector. Now r mod will be how much? 5 square plus 1 square plus 1 square root over 25, 26, 27 root over. Clear? This will be 6 minus 1, 5, and this will be 1, this will be 1. 25, 1, 1. Yeah, correct. So now if I write down the electric field at point due to this 5 coulomb charge will be K into Q is given as 5 coulomb divided by, or you just write 5 here, because for K also we are not writing the unit, na? So you just write 5 divided by r cube, that is 27 root over whole cube, r vector basically your what? 5 I cap minus j cap plus k cap. So like that you can find. If this charge is negative here, you just have to put a minus r here, right? That's what we have seen. Okay, clear? Like that you can find out. Okay, so one more question we'll see. Let's say this is along x-axis and this is along y-axis, right? So we can use this thing. This is along x-axis and this is along y-axis. Okay, now this is your x and this is your y. Now I put two charges here. I put one charge, oh, okay, here I put one charge, that is point charge, that we can take that plus q, and here I put one more charge, that is point charge basically, right? Plus q. Okay, I want to find out the electric field at somewhere here. I want to find out the electric field somewhere here. So let's take this whole distance from here to here is 2a. Okay, and this one you can take the origin, that means from here to here the distance is your a, and this to this distance is a. Okay, this one you can take the origin here, 0, 0 point. Okay, and this distance is basically, you can say that this is your 0 y, right? Or you can give this point name also. This will, you can tell that minus a0, and this point will be a0. Okay, this is the case. Now I am asking you to find out the electric field at this point P due to these two charges, right? So you know that from the point charge which is positive, the electric field will be radially outward. Okay. So the question is here, find electric field at point P due to these two charges, due to this arrangement, right? Or I can write here P due to two charges. What you will do here? You know that the electric field due to point charges will be radially outward if this is positive. So you'll say that due to this one, the electric field will be radially outward. It will be like this. And due to this one, this electric field will be along this direction. Clear? Now tell me this electric field will be how much? This electric field will be, I am writing the magnitude here, right? Electric field will be how much? You will say that this is Q charge, and if I know this distance, then I can find out. So if this is the y, so you can say that this distance will be y square plus a square barabar. Clear? So just a minute, I'll just take it down. Yeah. So electric field will be here. You will say that kq divided by y square plus a square, because root over will go away na? Now for plus q, here the electric field will be same thing, right? kq divided by y square plus a square. This will come. Now our work is to do the component division of the electric field. So this is your electric field. Because I write EE, because means you know that these two are same here, right? Same magnitudically, you can see that both are same. Or you can give the name, this is E1 and this is E2, right? Now I just do component division. First do component division of E1. So along this direction and along this direction, along X and Y, I am just doing the component division, right? So along X direction, I have to find out. So I just take this angle as theta and this angle also theta. Clear? If this angle is theta and this angle is theta, you can say that this will also theta, because these two angle are theta means what? They are telling that these two are from this two triangle, you can see now this two angle will be theta. If this angle will be theta, this angle will be theta. So this will give you, if this is theta, obviously this one will give you E1 sine theta, and this direction will give you E1 cos theta. Okay, and along this direction, if I do the component division of E2, you'll say that along this direction, this will be your theta, and this obviously E2 sine of theta, and along this direction, this will be again E2 cos of theta. So along Jacob direction or along Y direction, the electric field will be E1 plus E2 cos theta. That means same direction the electric field, we just to add up, right? But in along X direction, the electric field E2 sine theta and E1 sine theta are opposite, so both will cancel out. So I can say that E net along X is basically 0. Now E net along Y will be E1 plus E2 cos of theta. And you know that E1 is equal to U2. E1 equal to U2, right? So I can write this will be, let's take E. So E will be 2E cos of theta. So 2 into E will be how much? KQ divided by y square plus a square into cos of theta. You see, cos of theta can be written as y divided by a square plus y square root over. Put everything here. You get 2kq y square plus a square into y divided by a square plus y square root over. This will be 2kqy divided by y square plus a square 3/2. So this will be your net electric field at point P, which will be obviously along j cap direction, right? That's what we written, net along. So E along the x will be 0. So if you write down in the vector form, E net will be 0 I cap plus 2kqy divided by y square plus a square 3/2 j cap. This will be the net electric field. Okay. Similarly, you can try this one. You just try with taking the same arrangement, only one will be minus. So I am doing this one. Just this is x, this is y. Now here one charge I put minus q. Here I put a charge plus q. This will be minus a0. This will be a0, right? This will be minus a0 point, a0 point. Now this is your somewhere 0y. You have to find out the electric field at this point P. Find electric field point P due to two charges. So you can find out this one. Okay, just try. Okay, so what you will do now, you have to find out the net electric field. So you will say, just I am taking this one down little bit. Okay, so for positive charge, the electric field is radially outward. So it should be radially outward. Clear? So just a minute. So it should be radially outward. Okay, and it will be along this direction. This will be along this direction. Okay, let's keep this one E1, or you can put E2 also. Okay, now for minus q, you know that the electric field will be along negative direction. Okay, so for negative charge, the electric field will be radially inward. So the electric field direction will be along this direction. Let's keep this to E1. Okay, now our work is to find out the electric field at point P. Now you see here, this is E1. So I just take this one is theta. So obviously if this one theta, this one obviously be theta, because this is a distance, this is a distance. So this distance is a and this distance is same arrangement. I just change one charge minus q. So I just do the component division of E1 first. Okay, so just see. So if I do component division of E1, I will say that along this direction, minus z direction, this will be E1 cos of theta, and along this direction, that will be E1 sin theta. Similarly, if I do E2 component division, this angle will be theta, because this is theta, this will be theta. So along this direction, E2 cos theta, and along this direction, E2 sin theta, right? So if this same direction, you can add both. So now E net along y will be 0, right? Because E2 cos theta and E1 cos theta also same, because you know that E1 will come as, we have seen right there, kq divided by a square plus y square, and E2 also come as kq divided by a square plus y, because I am writing the magnitude, I am not talking about the direction already taken care by the arrow mark here. So E net along y will be how much? If E1 equal to E2, so here you can say that E1 equal to E2, so upward plus j kept direction E2 cos theta, downward it will be E1 cos theta. So you can say that E2 cos theta minus E1 cos theta is equal to 0. Now E net along x will be, this is basically minus x direction, right? So I can write E1 sin theta, E1 sin theta plus E2 sin theta, right? Minus I cap direction. This is I cap minus I cap direction. So E1 equal to E2 in Ona. So I can take it out. So this will be basically, if E1 equal to E2, I can simply write this one 2, this is E, let's say take 2E sin theta minus I cap. So this will be your 2 into E will be how much? E will be obviously kq divided by a square plus y square into sin theta minus I cap direction. 2kq divided by a square plus y square. Now see how much sin theta will be. Sin theta will be just here, na? Sin theta will be obviously a divided by a square plus y square root over a square plus y square root over. So you will get 2kq minus j cap direction, sorry, minus I cap, right? This will be minus I cap. So 2kq, this will be minus I cap direction. This will be 2kqa divided by a square plus y square 3 by 2 minus I cap. So E net will be 2kqa divided by a square plus y square 3 by 2 minus I cap plus 0 j cap. This will be a result, right? So we can find out like that. Okay. So next we will see for the electric lines of forces. Okay, next class we'll see.